Alrighty, in this video we are going to start putting together our component map. Now the component map is an incredibly important aspect of the system, and it's pretty vital for making the system an even viable option. And what do I mean by that? Well, if you tried to do RPC in the past, that will allow you to write code that you saw in the last video, you would have to waste a lot of bandwidth, as well as require a massive hit to performance by doing reflection and sending strings of method names across the wire and so on and so on. So I really wanted to come up with a way that would allow me to very efficiently indicate to the client or the server which methods should be invoked on which components. So what we need kind of a way to turn a class, a type, like system.reflection.type, into a identifier that can fit in a single byte. In addition, every one of these components will also have all of their methods mapped, and each method will correspond to another type ID. And again, that ID will also be a byte. So to select a particular method on a particular component, be it a actor RPC interface or a client system, you need a total of 2 bytes, which is perfectly reasonable for selecting an action to perform on the client or the server. Now, in some systems, you might see people getting away with using a single byte to indicate the operation, and that does work. You could do that, but you would be, of course, limited to 255 unique operations. Whereas with this 2-byte approach, we are able to provide at most 255 to the power of 255 different operations that we can perform on either the client or the server. And the separation does make sense in my opinion, because it allows us to separate our components with our methods. Now, it's also important to note that the component map needs to be very flexible, because we're actually going to have 2 instantiations of this object on every client and 2 instantiations for every server. So the 2 instantiations, one will be for client systems and the other one will be for actor RPC interfaces. So for example, we could have 255 different client systems and 255 different actor RPC interfaces, which I think is a perfectly reasonable amount. Now, if we wanted to go a little bit more crazy, there are ways we could do things like bit packing. Maybe decrease the amount of bits needed for most requests down to 8, or even make it so that we could support even more than 255 operations for particular components. Now, that is something that we could certainly add in the future if need be, but for now, I think that 255 actor components, 255 client system components, and 255 methods per either component should be enough for what we're trying to do at this time. But I just want to point out that this design won't be limiting. So the component map's responsibility is essentially mapping different class types and method infos to IDs, which are bytes. And it'll do this in the form of mostly object arrays. And then alternatively, we could also have dictionaries to help with the mapping from one to another in certain scenarios as well, though we would want to limit the amount of times we access a dictionary as much as possible. So we'll see how we can do that here shortly. Another responsibility of the component map is to cache method invocations. So we'll be seeing at some point here while we're building the component map, maybe not in this video, but we do need to be able to use the component map to invoke methods on particular objects. So for example, let's say we have a login system object on our client, we would need a way in which to invoke a particular method on that object, given only 3 things: the ID of the component, in this case the login system, the ID of the method, for example, login with token, and then a object array representing the arguments to that method. Now, I don't want to use reflection for this, or at least the methodinfo.invoke method, because of how slow it is. So instead, we're going to come up with a way that'll allow us to dynamically compile code that'll create only one additional level of indirection and allow us to invoke those methods directly, either on clients or on, client systems, or on actor interface RPCs, or RPC interfaces. So anyway, the way that we're going to be developing this, and really the way that we're going to be developing most of this system before we have enough components to actually plug it into Photon and Unity, is that we are going to be individually testing these components with unit tests. So we'll be putting together a unit test project inside of our solution. At some point, we'll also hook that into the continuous integration tool. I haven't decided when to do that yet, though. And then that'll allow us to be relatively certain that our code is working properly. All right, the first thing that I want to do is in the buzzmmo.base project, I do want to introduce a new namespace, and that's going to be the infrastructure namespace. So I'm going to come up here and create a new folder, and I'm going to call it infrastructure. And then I'm going to take all of the extensions namespace, the build number attribute, and the time classes, and I'm going to cut them and paste them into the infrastructure folder. And then I'm going to use ReSharper by clicking on the infrastructure folder and holding down Control-Shift-R and say Adjust Namespaces. And then hit Next. Now for those of you who do not have ReSharper, basically all that did was changed two things. It first changed where the BuzzMMO base namespace had added the .infrastructure to it on each 4 of these classes, and then it also went and updated all usage to have using BuzzMMO based infrastructure. I also want to check though to make sure that our build tool up in the update build info does not reference that new location for the build number attribute. So I will have to go into the build tool and add .infrastructure to that as well, so that our builds do not error out. But anyway, I'm just doing that because I'm doing this preemptively before we get a bunch of dependencies to these classes in here, because there are going to be a couple other top-level namespaces we're going to add to this project, and I wanted to keep it relatively clean up there. So I just dumped all the stuff into the infrastructure. I consider the infrastructure namespace on the various projects to kind of be like the framework code for something. Something that you want to put out of the way, but you still want to be able to access, stuff that is reused in a lot of different places. Okay, so there's our infrastructure folder. Now let's go ahead and set up a test project, and then we'll create our component map class, and we'll get a couple methods out of the way. We'll want a variety of different bits of functionality on the component map, but let's go ahead and start with creating our test project. I'm going to right-click on the solution and say Add New Project. And then over here on the left, I'm going to jump down to Windows, go into Class Library, and I'm going to create buzzmmo.tests. And I'm going to hit OK. Ignore that. Blah, blah, blah. You guys saw nothing. Really? Oh, derp. Alright, let's go ahead and hit OK a little harder this time, and we get a class project. So I'm going to go ahead and close out all that. I'm going to jump into tests. I'm going to remove class1.cs, which I don't even know why it auto-generates a class1.cs, but whatever. Then my mouse is going to freeze for a moment here while stuff happens. And then I'm going to right-click References and hit Manage NuGet References. And I'm going to wait for it to retrieve information. Actually, no. Oh, there it goes. And then I'm going to type in nUnit up here at the top right. I'm going to bring in nUnit. Then I'm also going to type in Fluent Assertions at the top, because I want the Fluent Assertions NuGet package as well. Now I want both of these installed to our buzzmmo.tests project. So this will allow us to not only use nUnit for our unit testing framework, but it'll also give us some helper methods to provide assertions. I typically prefer the Fluent Assertions library over the default assertions or one of the many other assertion libraries out there. Now the Buzz MMO tests project is going to contain test code for the entire project. So it's going to contain test code for the base, the client, the Unity client, the server, and so on. So what I'm going to do is I'm going to separate each one of these projects by namespaces within the Buzz MMO tests project. So I'm going to go ahead and create a new folder, or a new namespace, and I'm going to type in base. Then I'm going to create a new class, and I'm going to call it component map tests. Now in nUnit, it's typically considered good practice to go ahead and annotate one of your test classes with the test fixture attribute. So I'm going to go ahead and do that. You'll notice it brings nUnit.framework up at the top of my file. And then I'm going to go ahead and close out of that. See, you'll notice that I'm not getting a proper syntax highlighting on this attribute. You guys might be. I've noticed this to happen actually fairly frequently. ReSharper will just decide for whatever reason that it's not going to highlight something or recognize something. At least I think it's a ReSharper issue. I'm going to first try to close Visual Studio and start it back up again. That'll be my first attempt of fixing this. If this does not work, I'm going to close Visual Studio again and delete the ReSharper cache folder within the solution. But I'm just leaving this here on video in case you guys get a similar problem. And then I'm going to wait 2.5 million years for Visual Studio to actually get its act together and launch the solution, and I'm just filling the void of silence with arbitrary words that really don't mean anything. Words, 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 and let's see if we get that syntax highlighting action back there again. Now we do. Okay, so just need a little restart. Okay, so now that everything is properly highlighting and I get my code assistance, let's go ahead and let's build just a really basic test. And just so we can see what the actual usage of the component map class is going to look like, or what we're wanting it to look like. So I'm going to go ahead and say public void. Now, since I already have component map tests in the name of the fixture, I'm not going to worry about naming the actual individual test cases with component map. Instead, I'm going to assume that the names of each one of these tests is effectively prefixed with component map. So I'm going to name this test. Okay, well, what's the first thing that we want the component map class to actually do? Well, we want to be able to tell it that we should have a component and it should have a particular ID. Then we need to be able to retrieve that component using that ID from some sort of property or method of the component map. So let's go ahead and say, call this manually maps component. Okay, in addition, I'm going to go ahead and add the test annotation to this to indicate to Visual Studio and to nUnit that this is a test method. I'm also going to go ahead and do some test cases. And so this is a really cool feature of nUnit, where what I can do is I can have this one method accept a couple of parameters and then fill those parameters in with as many test cases as I want to run. Because there's two primary variables that we need to deal with here. One is the type of the component we want to map, and the other one is the ID that we want to map it to. And I want to test a variety of edge cases with the ID that we map it to. So what I want to go ahead and do is have this test case accept two parameters, a type, which is acquired from the system namespace, and I'll call this component type, and then a byte component ID. So that means that for every test case, I have to provide a type and a byte, which a byte will be a value between 0 and 255. So what components do we want to map here? Well, if it works for one type, it's probably going to work for all of them. So what I'm going to do is inside of this test fixture, I'm going to create a class called test component. and I'm just going to leave it empty just like that. So what we're doing is we're effectively pretending that this class here is just an arbitrary type. Actually, it would be a little bit more, it'd make a little bit more sense if this were instead an interface. Although at the end of the day, the component map doesn't distinguish between classes and interfaces, the reality is that all the components that we're going to map against our component map will be interfaces. So I'm just going to say interface, interface iTest component. Okay, so now we have a interface that we can work with. So again, to reiterate the goal of the component map, we want to be able to map this particular type to a particular ID and then retrieve that information later down the road. So let's write a couple test cases first, and then we'll fill in the body of our actual test. And again, we're testing against non-existent code at the moment. We're just setting up our test case, writing some code against a non-existent class, and then we're going to write that class to match the interface that we decided on during this design phase. So I'm going to say type of iTest component. So what are some good things to try to test this process, this manually mapping a component? What are some good values to put into component ID? Well, typically you're going to want to do things like byte dot, you're going to want something like byte dot min value. And then we'll do another test case. And we'll pass in byte dot max value. See, because we are wanting to map any type with any ID, a good set of test data to work against are going to first of all be the extents of the value that we can put in, so between 0 and 255. And then we can also throw in test case type of iTest component. We could also throw in just an arbitrary value like, oh, that's way bigger than a byte can hold. That's also way bigger than a byte can hold. There we go. 153, just another arbitrary thing. And let's also throw in 1 for, whatever. Okay, so what's going to happen with this particular test? If you're not familiar with nUnit, you might be actually a little bit confused. I probably should have started with a small discussion about what nUnit is and why we use it. And for people who aren't familiar with unit testing, or testing in general, nUnit is a library that allows us to write self-testing code. It allows us to write code that tests some other aspect of our project. And primarily what you're going to want to do is going to be 3 things. You're going to want to set up some sort of fake environment for your objects to live in. Then you're going to want to do something to those objects. And then you're going to want to verify that the expected result happened. This is commonly abbreviated as arrange, act, assert. So the arrange phase is when we kind of spool up a fake test environment for our objects. Then the act phase is when we do something to those objects. And then the assert phase is when we say, okay, so we did these things to these objects, now we should expect these results. And if we don't get those expected results, we consider the test to be failed. So what you're going to want to do is you're going to want to write these tests, and there are a million different ways to structure tests. There's a bunch of different test frameworks, and so on and so on. There's also many ways to name your tests, and I'm not going to get into any of that. I'm just using some very basic, straightforward, very loose conventions here. And then you're going to want to run these, or write these, and then you run them against a test runner. And once all of your tests pass, you are fairly confident that the things that you tested should be working. So again, what we're doing here is this test is actually going to be 4 tests. Now, first of all, we know it's a test because we have the test attribute. You'll notice that by adding the test attribute, ReSharper now has this cool little button right here that allows me to run the actual test. If you don't have ReSharper, you're going to have to use the nUnit GUI runner or the nUnit console runner, and you can read up the documentation to learn how to do that. Alternatively, I'm actually not entirely sure, but Visual Studio 2013 might have nUnit support. I can't remember. Either way, so this test attribute indicates to our tooling, be it Visual Studio, ReSharper, or the other test runners, whereas these test cases say that, okay, so this is a test. This is one test, but we're going to run it 4 times, and we're going to provide these arguments for each time that we run it. Now, you don't have to do this. I could make this test with not accept any parameters, and we will see examples of that, I'm sure. But in this particular case, I want to be able to test mapping a component to a particular ID for the min value of byte, the max value of byte, an arbitrary byte, and 1. And these are some good kind of wide-ranged values to use when testing. Okay, so let's write some code against a non-existent class. And this will also feel very weird for people who aren't familiar with this sort of technique, but I highly advise that people do get familiar with it. Because what it allows us to do is it allows us, like I said in the last video, to write code that, well, doesn't really, it's not actual code that'll run, but it gives us an idea of how we want to structure our relationships between our different objects. So I'm going to say var component map. So again, component map is an object responsible for storing the relationship between a type and a byte ID. So this is our arrange step. Now we are arranged because we only have one object that we need for this test. Then I'm going to say component map, and then I'm going to say dot, and then I have to think about what should the method be called that I'm going to have to invoke in order to manually map a component. I suppose I can go ahead and call it map component. And then I'm going to supply the component type and the component ID. So what I'm doing here is I'm saying I want there to be one method that I invoke that will properly map a component. Okay, so now we've acted. So we've arranged and we've acted. Now we need to assert something. So what external aspect of the component map should change based on invoking the map component method? So you kind of have to think about this in a weird sort of way. You have to think, what thing should map component have done that I can observe outside of the object itself? Now this is a very important aspect of testing because it'll often underscore code that is either not properly structured or isn't actually useful. So this gives us an idea of thinking, okay, well, I've invoked that method. What things should have happened that I can measure to make sure that that method had the intended effect? Well, let's think. One thing that we need to be able to do with the component map is retrieve a component out of a ID. And we also know that we want to store this in an array. Now, what type of array do we want to store this in? Well, I'm thinking that we should introduce a new class, a class that represents a mapped component. The reason I'm thinking that is because when we map a component, we're not actually done yet because we still have to map the methods on the component. So we need some sort of class that can store information about a mapped component. So what I'm going to do is I'm going to say var mapped component equals component map dot, and now we have to think, what should the property be that would retrieve us an array of mapped components? Well, I'm thinking a good name for that would be components. Also, in the interest of speed, I intend this to be an array that'll be indexed by component ID. So now that I've done that, there's a couple things I need to do. First of all, I need to ensure that mapped component is not null. Second of all, I need to ensure that the mapped component's type is the component type that we mapped. And finally, I need to ensure that the component ID is the actual ID. So I'm going to say mapped component dot should. Now I'm going to use Alt-Shift-Space. Come on. Well, it's not going to let me do that because it doesn't know the type of mapped components. I'm going to go ahead and do this manually. I mean, you rarely will ever see me do this ever when I code, but I will go ahead and introduce a namespace import here at the top manually. I'm going to say using fluent assertions. And that's still not going to give me autocomplete. And the reason it's not going to give me autocomplete is because it can't infer the type of mapped components because we are working against a non-existent class. So just ignore all that. Make sure that you do have fluent assertions up at the top anyway, because we'll need that later. So I'm going to say mapped component dot should not be null. And that'll throw an exception and fail the test if this object is null. Next up, I'm going to say mapped component dot type. So now I'm doing some more design work. This is how I design software, or I design components. And what I just did is actually not insignificant. What I said is, I want to now make sure, in my mind this is what I said, I want to make sure that the component type of this mapped component, the actual system dot type, the actual reflection type, is of the type that I passed in when I mapped the component initially. But that requires that I need to gather some data from this mapped component object. Well, I don't have any properties on it currently because it doesn't exist. So I need to think of, well, how should I be able to retrieve that particular bit of information from this mapped component? And I thought, well, a great name for a property could be type. And so I typed in type right there. Again, it doesn't exist. None of this code exists yet, but I'm just kind of designing how I think it should look, and then I will turn this into a real class here momentarily. So I'm going to say mapped component dot type should be component type. Now the final thing that I want to ensure is that this mapped component's ID is the same ID that we passed in to map the component initially. So I'm going to say mapped component dot ID should be component ID. And that's my test. Now technically this is 4 tests, but we just had to write one method, and then we use the test cases to have it run this method multiple times with different arguments. So anyway, so that is so far the most basic functionality of our component map, and basically what I want to provide. So now let's go ahead into the Buzz MMO base project and actually write the component map in such a way that the API will work with this code I wrote. Because this code is kind of, think of it like a wish list. I want this class to behave like this. Now I'm going to go and make a class that behaves just like this. And with any luck, we won't even need to change the test at all. We can just write the code based on the test entirely. Before I do that, the buzzmmo.tests project should have a reference to all the other projects that it's going to be testing. So I'm going to right-click References, and I'm going to say Add Reference, and I'm going to click on Solution over here on the left-hand side, and I'm going to add a reference to Base, Client. Actually, I don't think I'm going to put in Client Unity. I think I'm going to test that differently. And the reason for that is Client and Client Unity will share code files, which will result in conflicting classes. So I'm going to actually have to, by definition, use a different test project to test the Client Unity project. Let's bring in Data, Server, Server Master, and Server Region. Notice how I'm not bringing in a launcher or web. These are both front ends that have different concerns, and I'm not interested in testing them. So I'm going to hit OK and close out references. All right, so the next thing I got to do is I got to actually write the component map class, or at least make it exist. So let's click on the infrastructure namespace up here in MMO.base, and I'm going to create a new class, and I'm going to call it component map. Now, by creating this class, and by virtue of the fact that we have tests referencing MMO base, I can actually jump back into the tests and notice that ReSharper is now telling me to import a new namespace, which is pretty handy. So I can just click on that, and I get a new namespace import for Buzz MMO base infrastructure. And so you guys could just type that in yourselves if you don't have ReSharper. So now that we see we have map component and components, those are the two things that our component map should have on it. So what I'm going to do is I'm actually going to bring the test over here to the right-hand side and go into full screen, so we can kind of see what we want the structure of the class to look like while we write the class itself. So the component map is going to need a map component method. Now, what's the map component method going to return? Well, I know I'm actually kind of breaking the TDD mantra of thinking ahead a little bit, but I am going to think ahead in this case. What should this map component method return? You notice by the test itself, it should return void because we're not using any return value. However, in the future, I know that we're going to need to map the methods on a recently mapped component, which means that it does have to return something. And that something is going to be of the same type of retrieving that component out of our component map. So what I'm going to do is I'm going to say public mapped component map component type, which is going to import system, the system namespace, component type, byte, component ID. And so now you see that the red over here on the right-hand side is slowly going away, which is really cool. So what's the map component method going to do? Well, if we look at the test, we know that the mapped component should somehow influence this components property. And we've already decided that the components property is going to be an array of mapped components. So what I'm going to do is I'm going to say public mapped component mapped component array components get private set. And now more red goes away. In fact, at this point, we could get rid of all of the red by simply defining a class called mapped component and adding its two properties to it. Well, we can do that here in a second. The first thing I want to do is talk about this array. So this array, what I want to have happen is I want it to be actually initialized to 255 elements. Why 255? Well, that's the max value of a byte. So meaning we will have a block of contiguous memory that contains references to components, and they'll be indexed by their component ID, giving us a linear time lookup, meaning given an ID, I can find the mapped component by just passing that as an index into the array. But to do that, it'll require some initialization. Namely, I have to go ahead and instantiate the array. So I'm going to go ahead and do that. I'm going to create a constructor for our component map and say components equals new mapped component byte.maxValue. Now, I'm actually not concerned whatsoever of a person passing in any arbitrary index into this array. The reason I'm not is that C# comes with built-in bounds checking, or well, .NET in general comes with built-in bounds checking, and trying to access a component that isn't an index that doesn't exist, such as -5 or 3000, will result in an out of index exception, I believe. Either way, it'll result in an exception, which is exactly what I want, because that exception will stop the processing of whatever it is it's doing, because that process is obviously invalid in some sort of way. Remember, exceptions are not your enemy. Exceptions are very good because they tell us when our program is misbehaving. And it's important that we don't try to eat exceptions when we don't have any explicit error handling code to compensate for it. So again, I am just not worrying about exceptions whatsoever. I'm just going to let them happen if they happen, because that indicates a bug in the code, which is the purpose of exceptions in the first place. So for anyone worrying about me not doing any bounds checking, it's not a big deal, because the .NET framework will prevent memory from being corrupted and instead throw an error that we can log and examine later if that happens. Anyway, so we have our components. So what should the map component method do? Well, it really should just go ahead and say var component equals new mapped component, and then I'm going to pass in the component type and the component ID into its constructor. Then I'm going to say components at component ID equals component, and I'm going to say return component. I think as a sanity check, I will also ensure that the component ID hasn't already been mapped. So I'm going to say if components at component ID does not equal null, throw new argument exception. Component already mapped, component ID. Now we're not going to check to make sure that the type of the component has already been mapped. That would just be whatever. Not particularly useful, so I don't really care about that. But I do want to put in this small sanity check, and we will be testing this exception here shortly, so I can show you guys how you could test exceptions, which is really cool. Okay, so map component basically just instantiates a new mapped component, passing in the type and the ID, sets it to its array, and returns it. Pretty straightforward stuff. So now the last thing that we need to really do is create the mapped component class. So let's open up Solution Explorer, go into our infrastructure namespace, and I'm going to create a mapped component class. So now by creating mapped component, almost all of these errors disappear on both the component map and on the test, and that indicates I'm moving in the right direction. Two errors exist. One error is I don't have a constructor yet for my mapped component, and the other errors are that I don't have either of these properties. So let's go ahead and fix that. I'm going to create a constructor that takes in a type, which will import system, called component, or at this point, I'm just going to do type and ID. So I'm going to say type and ID. The reason I'm now doing type and ID is because I'm in a class called mapped component, so I assume that type and ID, unless otherwise qualified, will be referencing the concept of a component. So I don't feel the need to prefix either of these parameters with the word component. All right, so let's go ahead and turn these into properties. Let's go ahead and make them private setters, and boom. Let's go ahead and get all this code up on the screen at once so we can show you guys what is going on. And we now have the very basic map component. I know it's really not all that exciting what we just did, but I did just want to spend time talking about, what I'm doing and what's going through my head so that people can understand why I'm making these choices, because it's very rarely that I'm going to type something without deliberately deciding to for whatever various reason. So anyway, that's our test, that's our code. Let's run it. Also, I forgot to run it before it would work, but whatever. So to run this, if you have ReSharper, I'm just going to click on this little thing in the gutter up here on my test fixture. And I'm going to say run. And that'll pop up this handy little window, this handy little test runner. And you'll notice that this test runner has one fixture and 4 test cases. Oh, as you see, you already have a failing exception, a failing test, which is really cool, actually. Okay, so you see that we have, the way this is structured is we have the namespace the test is in, and then we have, or the project the test is in, sorry. Then we have the test fixture name, then we have the test name, and then we have the 4 test cases underneath it. So you notice that when we do byte.maxValue, we get a system.indexOutOfRange exception. The index was outside the bounds of the array. But all these other ones succeed. What that means to me is that our array actually needs to be byte.maxValue plus 1 items. It needs to be 256 items, which makes sense because 0 is a valid index. So it'll go 0 to 256. Let's come back up here and let's hit run again. And let's see if that fixed that final test case. And we get success. So as you see, by carefully choosing, writing your test and carefully choosing what you're testing, you can prevent or at least significantly mitigate the amount of bugs that you are going to have to deal with once you get into production. I honestly was not intending that test to fail. That was an honest mistake on my part, and I think it's really cool that it just blew up like that and showed us an outlined a bug right in front of us. Okay, so like I said, the last thing I want to test is when we map 2 components with the same ID. So let's go ahead and do that. I'm going to say, so this test, I'm going to go ahead and close out all of these other guys so we get some more room in our test, and I can go ahead and exit full screen. In addition, I could also move my test window maybe in place of my Solution Explorer. And then what you can do, which is really cool with ReSharper, is I can come up here to this button and I can select bottom, which will dump the output on the bottom, which is more appropriate when you have limited horizontal space. Okay, so let's go ahead and write a test to test that error condition. So I'm going to say public void mapping 2 components with the same ID throws exception. Now I'm not going to worry about parameterizing this test. I'm going to just leave this as a public void test, so I must annotate it with the test attribute, and I'm not going to accept any parameters. So let's go ahead and arrange. Let's go ahead and act. And, well, this is actually going to be acting and asserting. This is actually the assertion right here. So anyway, how can we test to see if this fails? Well, I could actually just say run, and you'll notice that it does throw an error, which is a good thing. I want this test to throw an error because I'm deliberately setting up an error condition. So it's interesting that I actually am wanting an error condition to happen, so how do I tell nUnit that I consider a particular error to actually be a test success? Well, to do that, it's very straightforward. All I have to do is create a delegate. So I'm going to say action. I'm going to call this fail condition, and say equals, and it's going to equal this line of code. So action fail condition equals this lambda, which is simply going to invoke this method. Now, if I were to run this test again, you'll notice nothing happens, which should be fair. It succeeds, and nothing happens should be fairly evident because I'm assigning this lambda to a delegate, but I'm not actually invoking the delegate. But what's really cool is the fluent assertions library allows me to say fail condition dot should throw argument exception. So what the fail condition will do is not only will it invoke this delegate, but it'll also make sure that this particular exception was thrown. So now if I run all my tests, I should get success. But how do we know it's working? Well, the easiest way to make sure that a test is working is to jump back into the code that you're testing, such as component map, and changing the code in such a way that will make it fail. So I'm going to go ahead and comment this error condition. So I'm going to go ahead and multi-line select here by holding Alt, comment this out. I'm going to come back here to unit test sections, and I'm going to hit run all tests, and I should get a failure. And I do. It says expected a system.argument exception to be thrown, but no exception was thrown. And that's precisely the behavior that I want. Well, the behavior of the test, not the behavior of the code. Obviously, the code is now wrong, and but I've assured blah blah blah. I've tested the test, is what I'm trying to say. Now that I've tested the test, let's go ahead and fix the code. Let's hit run all, and let's see a bunch of green, and we do. Alrighty, so we didn't write a whole lot of code in this video, but we did go over some incredibly important concepts, both in the design of our component map and also in testing in general. So I hope you guys enjoyed that bit. In the next video, we will continue with the component map. Basically, this is the pace, or not the pace, but the process that we're going to be going through for creating the RPC framework. We're going to go component by component, making sure that they're as tested as they can be given their design constraints, and then eventually we'll be able to have enough components written that we can wire them all up together and actually see some action in Photon and Unity. Anyway, we'll see you guys in the next video.